All right, in this section, we're looking at factoring things that look a little strange. They look really hard, and you think you're going to have to do a lot of work. But there's a quick way to do all these problems using substitution. And it's interesting in number one, the three problems in number one are basically going to be worked exactly the same way. All right, here's kind of the idea we're looking at here. Let's look at this problem we have here, and if you notice, there's something squared minus 5 times that same thing. See, here's the x plus 3, here's the x plus 3, and then plus 4. What if I just had this problem instead? What if I had, and I'm just going to use a u, okay? What if I had u squared? Just what I'm doing is I'm taking that x plus 3 and I'm replacing it with one thing to make it look easier, okay? This is called substitution when we do this. Everywhere we see a x plus 3, let's just put a u in there, okay? Minus 5, ooh, there's another one, u plus 4 equals 0. Now that's an easy problem to factor because you're thinking, oh, this is just a square. What do I multiply to get the 4 on the end, but at the same time it adds to negative 5? Well, we could say, well, negative 1 times negative 4 is positive 4, and negative 1 plus negative 4 is negative 5. So this would be easy to factor if we just make it look a little simple. We're just kind of faking our brain out here a little bit. You could say, okay, well, there's a u squared, so it's going to have a u and a u. And then I take this minus 1 and this minus 4, and I can factor that easier problem. Okay, well, that's done, isn't it? Okay, but that wasn't really the problem we had when we started, but it's easy to switch it back because everywhere we see a u, what are we going to do? We are going to stick back in now. We just made it simpler for a minute. Now we're going to stick back in the x plus 3. So it's x plus 3 minus 1 times, oh, there's another u, x plus 3 minus 4. So all I did was switch it out momentarily, then I stuck it back in. There was that pattern there, and we can have all kinds of things that look really hard to factor, but we can actually factor them if we see that there's a pattern to them like this, and this is what this whole section is about. So now, are we done? No, we'd want to clean up a little bit. This would be x plus 3 minus 1 is really x plus 2, and x plus 3 minus 4, well, the 3 minus 4 would be negative 1, so that's really x minus 1. And then if we want to solve it, we set it equal to 0 because they did tell us to solve it, and we just say, well, set each one equal to 0. Okay, so we'd get x is negative 2 on that one, and if we add 1 to both sides, we'd get x is 1 here. So our answers are 1 and 2, or negative 2. Okay, now the other two, the b and the c, are just this way. B says 2x minus 1 squared minus 5 times 2x minus 1 plus 4, 0. Do you see that if I took and look at what they're using in parentheses, and I said, well, this time let's let, I'll use a different color, let's let u equal 2x minus 1, we would get, okay, everywhere I see 2x minus 1, I'm going to call it u. That's u squared minus 5, oh, there's a u, plus 4 equals 0. Look at this. Isn't that the same thing as what I had up here? So I know how to factor it. It's u minus 1, u minus 4. I already did it once. They're just trying to show us that this pattern can look like anything here. U minus 1, u plus 4 equals 0. And then what we would do next is say, okay, well, that's nice, but that wasn't really what I had. Well, that's okay. I know what u is. It's 2x minus 1, so we'll go stick it back in now since we've made it a little easier just momentarily, so we could factor it. I get 2x minus 1 times the other one would be 2x minus 1 plus 4 equals 0. And then you could go solve that. I'm out of space, so I'll leave that for you to do, but you would just say, well, that'd be 2x minus 2 times 2x. Let's see, 2x minus 2 times 2x plus 3 equals 0. And we could solve those pretty easily. Let's look at the c part. The c part is x to the 4th minus 5x squared plus 4. And again, We've done something like this before, but I didn't really show you the formal substitution. But here's what we could do. We could say, well, isn't x to the fourth x squared squared? And then you got 5x squared plus 4 equals 0. And then what I could do is on this one, to show you that it's the same as the others, is let u equal x squared. So everywhere I see a x squared, I'll put a u. Well, here's 1, so that would be u squared. Well, there's another x squared. That'd be a u. And when I get it, it's the same thing as we had on the a and the b parts, isn't it? That we know this factors into u minus 1, u minus 4 equals 0. But we didn't really have a u. We had an x squared. So let's go switch it back now. We're just temporarily using the u, and then we're going back to what it really was. So that's x squared minus 1 times x squared minus 4 equals 0. So actually that factors further. I can look at that and say, hey, that factors further. That's x minus 1. That's the difference of two squares right there, isn't it? X plus 1. And in this next one, it's also a difference of two squares. It's x minus 2 and x plus 2. And if I want to solve this, I just say, set each one equal to 0. So we got 4 of them. And then we would get, if we added 1 to both sides, that first one would be x is 1. If we subtracted 1 from both sides, the second one would be x equal negative 1. On the third one, if we add 2 to both sides, we'd get x is 2. And on the fourth one, if we subtract 2 from both sides, we get x is negative 2. So the answers here, if I put them in order, would be negative 2, negative 1, 1, and 2. Now, you may remember that in the past we factored that without using substitution. We said, what we could do is say it's x to the fourth, so we could put an x squared here and an x squared here, and then we would have our minus 1 and our minus 4 like we've had on the other 3 cases here. You don't have to use substitution if you don't need to. Some of you may be able to do it without using the substitution. And maybe some of them you can do without substitution and others you need to do. The thing that's kind of cool about substitution is we use it heavily in calculus to rewrite functions. So it's kind of good to practice it now because it'll just make it that much easier for you in calculus if you take it. All right, if you look at number 3, again, what we see is we got 3 things to factor, and they're going to factor basically the same way once we substitute a u in. It's just that they're going to have really different looking things that we're substituting for. So that's a pattern you should notice in A, B, and C on 3. I don't know if I'm going to work all of them. I may set some of them up, but we'll see. I know this one looks a little weirder because it's got some fractions and stuff in it. All right, so what if I let u, in this case, we're going to use substitution. Let's let u equal 1 over 2y. Okay, so this would turn into 2u squared, because there's a u and here's a u over here, so it would be plus 5u minus 3 equals 0. Now you could do factor by grouping, splitting the middle term if you need to, but since we've got a prime number here and a prime number here, this one usually is a little harder one to factor than like the previous example. But if it's 2u squared, I know it's got to be a 2u and a u. And if it's a 3 at the end, I know it's got to be a 3 and a 1. How can I combine these things to come up with a 5 somehow? Well, I know that 2 plus 3 is 5, so I don't want to multiply probably the 2 and the 3 together. I might need to. It just depends. Actually, I think I am going to have to. I thought that would work, but here's what I think is really going to work. What if I do multiply the 2 times the 3? That would be a 6. And remember, I'm trying to get a plus 5. If I had a plus 6 from that multiplication, and then I had a minus 1 from this multiplication, 6 minus 1 would give me 5u. Okay, so I could factor it that way. Now remember, this is the factoring right here. I'm going to circle in yellow that we're going to use for the B and the C part as well. We don't have to go redo it every time because it's the same basic problem underneath. Or the same basic factoring underneath for the B and the C parts. But for this one, I say, okay, that's all nice and everything, but it really wasn't a u. It was a 1 over 2y, so we'll go back in and we'll say that's 1 times, we'll just substitute back in now. 2 times 1 over 2y minus 1. And over here we have 1 over u is 1 over 2y, so we put that back in, plus 3. So all I'm doing, if you're confused, is I'm taking the u, I have to do that in red, taking this u and I'm putting back in, since u is equal to 1 over 2y, I'm just taking it out and putting the real thing back in. Alright, so that looks a little weird, doesn't it? But we know that those two things multiply to give us 0. So let's simplify. 2 times a half would be 1 over y, so this would become 1 over y minus 1. And then over here we have 1 over 2y plus 3 equals 0. And you say, oh, but that looks weird. What am I supposed to do with it? Well, they're two factors. Even if they look weird, you take your two factors and you set them equal to 0. And something that looked like it was impossible to solve all of a sudden became possible. So take 1 over y minus 1 and set it equal to 0. And then also take that 1 over 2y plus 3 and set it equal to 0. So we just need to solve for y in each case. We could add 1 to both sides. We get 1 over y is equal to 1. Let me make that into a proportion. I got a fraction on the left. I could change the right into a fraction, and I could cross multiply. Y times 1 is y, and 1 times 1 is 1. So there's one answer, y equal 1. Remember how I kept telling you in previous years that proportions show up everywhere? Well, they do. If you can just keep your eye out for them, they're there a lot of times. If we have a fraction on one side and on the other, we can cross multiply. And sometimes if we have a fraction on one side, we can create a fraction on the other side easily. That's what we'll do over here as well. Let me subtract 3 from both sides first. And that would be 1 over 2y equal negative 3. I'm out of space here. Alright, what I'm going to do is turn the negative 3 into a fraction. Just put it over 1. And it would be 2y times negative 3. I'll come up here where I've got a little space. That would be negative 6y. So I'm working up here now. And then 1 times 1 is 1. If you look at the other diagonal. If I want to solve for y, then I can divide both sides by negative 6. See how much just basic solving is just always showing up also. So we get y equal negative 1/6. And that's our other answer. Now this factoring pattern for this 2u squared plus 5u minus 3 is what we're going to use in the other problems as well. So I'll do as much as I have time for. I'm probably running pretty low here on time. So it's 2u minus 1u plus 2u minus 1 u plus 3. So for the b part on this one, it would be